the second operation of vectors. The first thing we have learned, the first operation we have learned was dot product, and we said that the result of the dot product is a scalar, a number. Today we are going to learn the second operation, which is cross product. And this is vector product because the result of the cross product operation is a vector. So let's say we have vector A and we have vector B, and the angle between A and B is theta. So we are given the vectors geometrically, so I know the magnitude of vector B, and I know the magnitude of vector A, and I know the angle between their tails. So I know the vectors geometrically. If I want to find the magnitude of A cross product B, so let's write it like this: A cross product B will be the magnitude of vector A times the magnitude of vector B sine the angle between them. This is the magnitude of the vector that is the result of A cross product B. Okay, so this is the magnitude of the vector of the cross product. Now, any vector must have a magnitude and a direction. So, what will be the direction of this vector that is the result of A cross product B or B cross product A? The result of the direction of the vector, the cross product, the result of the cross product of two vectors is perpendicular to the two vectors. So let's say this is vector A and this is vector B, and I'm doing the cross product. The result of this cross product operation will be this vector that makes 90° on both vectors. This vector that makes 90° on both vectors. Okay, it's either this way or that way, and I will tell you how we determine if it's going up or down. Or so if A and B is in this direction, the vector will be perpendicular like that, make a 90° on both. Okay, so if we have, let's say this is vector A and this is vector B, the result when we do cross product will be a vector that makes 90° on both A and B. Imagine this is a 3-dimension, so those two vectors are like this and this one is like that. Okay, how can we determine if it's this way or the other way? We use the right hand rule to determine the right hand rule. It has to be right hand. So we use the right hand rule to determine if it's going up or down or in. So when we are doing it in the board, it will be inside the board or outside the board. So let's say that I'm doing A cross product B. I'll put my right hand in the direction of vector A, so my fingers going with the arrow. Then I will curl my fingers towards the second vector B, and my thumb will be the direction of the cross product vector. So my thumb is here. So, some person say, okay, why don't you go the other way? I cannot curl my fingers to reach vector B unless I break my wrist, right? So I have to go this way and my thumb will be here. Let's say I want to do, so this is out of the board. The direction is out of the board. Let's say I want to do the opposite. B cross product A. I'll put my right hand in the direction of B and I try to curl my fingers to reach vector A. I will not be able, if I do it this way, I will not be able to do that because my wrist will be broken. So I have to put my right hand in the direction of B, but in this way. So my fingers are going with the arrow, and then I curl my fingers to A. That's easy, and the vector will be into the board. Okay. All right. So the right hand vector, the right hand rule, tell us the direction of the cross product. From there, what we know, the magnitude of A and magnitude of B and the angle between them is the same. So the only difference is the direction when I do A cross product B and B cross product A. So B cross product A will be down there and with the same magnitude as this vector. So from there I can tell that A cross product B equal negative B cross product A. Same magnitude, opposite direction. Okay? This is how we find the cross product if we know the two vectors and the angle between them geometrically. Now we learned that we can know the vectors algebraically with components, 3 components, x, y, and z. So let's say we have vector A is A1, A2, the components are A1, A2, A3, and vector B is B1, B2, B3, and I want to do the cross product of A cross product B. So what I do is the following. I write I, J, K, which are the unit vectors in the directions of x, y, and z. I write the components of the first vector first, so A1, A2, A3. Then I write the components of the second vector, so B1, B2, B3. Then I will go with the first unit vector, I. Then I ignore the column and the row that contains I. So this and this are not there. Then I will do A2 times B3. So I do like this. Then minus A3 B2. Okay? Then minus J. So I am now, it has to be minus the J. So plus, minus, plus. This is the way we do it. Okay? Now minus J. I will forget about the row and the column that has J. Now I will go from the top left, so A1 times B3 minus A3 times B1. Then I will do plus K. I ignore the column and the row that has K, so now from the top left, A1 B2 minus A2 B1. This is how we do the cross product. Okay? There are many other ways, shortcuts and stuff you will see somewhere else. I like you to use this way because it is introduction to linear algebra, a big topic in math, big branch. So I want you to learn this way. It will help you a lot in university. So now I'm going to give you an example of how to do cross product. So let's say vector A is negative 1, 1, and 2. Vector B is 0, 3, and 1. Find A cross product B and use it to find So A cross product B, I will write I, J, K. I will write the components of the first vector first, so negative 1, 1 and 2. Components of the second vector 0, 3, 1. Then I will start I, forget about the row and column, 1 times 1 minus 2 times 3 plus minus j. So plus minus j. Then ignore the row and column that contains j. Negative 1 times 1 minus 2 times 0. Okay, plus k, which is, ignore this row and column, so that will be negative 1 times 3 minus 1 times 0. I hope I didn't do mistakes. Yes, I didn't do mistakes. So 1 minus, so I, 1 minus 6 is negative 5i. And here we have negative positive 2. No. 1 times what? J was negative 1 times 1. Okay, times 1. So this is negative 1 times 1. Negative 1 times 1 is negative 1, minus 0 is negative 1, so negative will be positive j. Then minus 3, minus 0 is nothing, so minus 3k. Now I can write this as negative 5, comma 1, negative 3. What we know about this is the vector that is perpendicular on both A and B. So if this is A, I'm not sure how A will look like, but if this is vector A and the components is negative 1, 1 and 2, and the other vector B is 0, 3 and 1, this vector is the result, which is A cross product B, and it has components negative 1, 1 and negative 3. This is the components. Of course, I can get the magnitude of the cross product if I do square root of these components, negative 5 squared plus 1 squared plus negative 3 squared. This will be the magnitude of this vector, and we know the components, so we know the direction. From there, I can find B cross product A, because it will be exactly the same numbers, everything multiplied by negative. So negative A cross product B, which is 5, negative 1 and 3. So the other one will be B cross product A. The direction of this vector makes 90 degrees on both. Okay, I'm not sure if I can do another example, or so I will do another video then. Alright, so see you soon.